the big light on top, the red light, recording.
You're recording.
Recording.
Yes.
See, right now, this is being taken in the days of where all your staff is actually working at home. Normally, we work by ourselves, and then the rest of the staff happens to be around, so you might hear all kinds of sounds behind. Oh, Larry is locked in a room, so he's lucky. I'm not. So you can probably hear some sounds. Speaking of being sounds, this is the case of really quickly. I might get cut off during this show, and you'll understand why. Because the cable guy, or the cable person, I should say, literally is going to cut my cable, put in, instead of the white wire, a black wire, because apparently the white wire absorbs more sun and causes problems, and the black wire, it's counterintuitive, but apparently that's the case. So that's about to happen. This is crazy stuff. If you want to be in the cloud, you better be connected with a black wire, apparently. So there's our tip for today. Black wire.
Better than red pill versus blue pill is black wire versus red wire.
Absolutely. And speaking of which, our guest star is here. Larry, why don't you introduce everybody? Let me hit dismiss while I'm at it.
Well, I'll introduce myself, and I'll let Rob introduce himself. Rob and I worked together at Dell for a little bit, and actually we didn't overlap for very long, but this is the Cloud Talk show, and Ralph Rivas and I have been doing the Cloud Talk show for a little bit, trying to talk about the cloud in an informal sort of car talky way. So
oh dear.
Yes, exactly. So we're irreverent. We try to be moral.
Without Boston accents. No heart attacks over here.
From the old guys that have been in the trenches for a long time, because there are these young kids that are out that don't know what TCP/IP even means, or they don't know what an iDRAC is, or anything about servers. What's a server?
That's true.
Oh my God. And Rob is working with bare metal, and people don't see bare metal anymore. They don't know what it means, and it's. So
some
Rob,
people think bare metal. Some people think bare metal is like a heavy metal band. It's like, it's bare metal, man.
Right. A bunch of grizzlies performing.
Right, with lots of hair. Yes. Right.
So Rob, if you don't mind, talk a little bit about RackEnd and where you're coming from, and I noticed your posts. You've got some directions that you're going, that all this COVID stuff is really kind of changing the way that we're looking at things, and anything you want to talk about, we're open.
That sounds great. Yeah, I am starting to spin up some infrastructure resilience posts and I'm trying to sense the timing, because I did one that I thought was really good, but it sort of fell flat because I don't think people are ready to talk about post-pandemic life quite yet. But I am very interested in what infrastructure resilience looks like. Everything that I'm seeing from that perspective shows IT is not going to, IT is going to boom, not bust with the COVID stuff. But RackEnd, oh boy. So RackEnd started out of, that experience you were talking about with Dell, where we were, helping people rack OpenStack and Hadoop systems, and, sort of look at what hyperscale data centers were doing. And we really found that there was a common thread, which was that every data center was different, and no data center had good automation at the bare metal level. And so what we kept seeing was that the failure patterns for people running data centers were sadly very, very similar, even though the data centers themselves were different enough that it made it a hard problem to solve, which is where infrastructure as code comes in, but we'll come back to that. So what we did with RackEnd was we said, how do we fix the root cause of this problem? How do we make it so that we can create portable automation, so something I can reuse site to site that still solves I need to provision things on bare metal. I need to set up my switches. I need to attach the storage. I need to basically do all that prep work. Because what we found over and over is if we did that well, installing OpenStack was not a problem. If we do that well, installing Kubernetes is really easy. And so that was really what we saw, is that the platforms themselves were complex. Not for the wrong reasons. There's just complex, platforms are complex. But since everybody set up their data center by hand and did it a little bit differently, as soon as you got into that each site, you built everything on top of it differently. And that's where things were going wrong. And so what RackEnd did was we went and built a platform. It's now in its 4th generation. It's called Digital Rebar. And that platform provides the abstractions that are necessary to run all of the interconnected systems in a data center from the physical layer upwards. And that's really so, and the thing that people don't realize with physical data centers and why it's so hard is there's no, like with cloud, it's beautiful. It's like I go to the API and I ask for something and it gives me something. And, you know, Amazon's API is relatively consistent for Amazon and Google's is consistent, right? They're very, VMware's is consistent for VMware. And as long as you're within that bubble, life is good. In the physical layer of the data center, there's nobody rationalizing your APIs. So, you know, you had mentioned iDRAC, which is a Dell out-of-band management interface. And, you know, the challenge is that even if you only talk to the iDRAC, you're only doing about 20% of the work to provision a server. And that's really what our big aha moment was. So when we talk about doing operations in a data center, because we start at the physical level, it means what we're really doing is orchestrating changes across different protocols. So that starts with, you know, DHCP and TFTP, which is a very primitive file transfer, HTTP, then HTTPS, right? And then all of a sudden you're interacting with all sorts of systems and you're switching from Linux to Windows or ESX, right? And then it becomes a soup of protocols.
Right. And you've got heterogeneous rather than homogeneous hardware, right? Because, you know, even if you order all of your systems at the same time, you're not necessarily going to get the exact same server.
That is the dirty secret for any of these vendors. Even if you buy from the same vendor, yes, you still get hardware variation. And people are like, oh, that sucks, it's horrible. It's like, no, it's needful.
Yes.
Right. You're laughing. Right. I have this funny story for Dell servers, where, you know, recently Dell came out with an addition to the RAID controllers that allows you to plug in SSD cards directly in, right? And it's a beautiful feature, but it adds in new drive arrays into the card. The new drive arrays are recognized. Great. It's an important feature, but it changes the automation of the existing cards without being a new rev of the server. So, you know, we have customers where they all of a sudden they start getting new Dell servers and they don't match the profile of the old Dell servers, but the model numbers haven't changed, so the specs haven't changed, but the automation has changed. And that's just a day in operations.
Right. And so the goal though is to put a layer of automation above it so that you can get a layer of software that can then get us to that point that we are in the cloud where we have this nice, beautiful, consistent, homogeneous API, be it Kubernetes or OpenStack or any of the other beautiful abstractions.
Abstraction's the right word. It's because we're not creating a virtualization layer. A lot of people think like, oh, are you replacing VMware? It's like, no, what we actually needed was an API that could say, give me a system, right? It's very intent driven, which is, you know, very cloud native, cool, focusy stuff now. We've been doing it like this for 10 years, but it's nice to have industry agreeing on the words. But the idea here with any of these APIs is that I go to an API and I say, I want a ESX server, or I want a Kubernetes node, or a master system, and so what you do is you can say, that's my intent. And then the system has to be able to figure out how to map that intent sort of backwards from all of the information it has. And the trick to mapping intents backwards is state. So what happens for what we do, so when a system boots, we start collecting data about it. When you take actions on it, you start collecting data on it. And that data accumulates or is injected in the system. This is the makings of the infrastructure as code story. But you know, because state is important. And so what happens is if I want an intent-driven system at the end, then I have to have a way to accumulate state as I layer on different capabilities. Right. And that has to survive whether I reboot the system or, you know, make changes to it. I have to have a way to come back and say, oh, okay, I just created some certificates for this system. Let me store that certificate so every time I reinstall the operating system, I get the same certificates.
Gotcha.
But it's layers of those things, hundreds of those things that make it happen. And that's what lets you go in and say, give me a machine to fit in this cluster. There's all this data that gets fed into delivering that system at the end of the day. It's one of the things that I find challenging with like Ansible. Watched a lot of people do Ansible integration, and you spend a ton of time building an inventory file and getting that inventory file just right. And that is actually the funny thing about Ansible. The hardest thing is Ansible is you've got to build all that data into the inventory file. It doesn't collect. There's no feedback mechanism. And if your inventory file is wrong, your whole install is wrong. That never felt particularly right for us.
Well, I mean, you're relying on something that it's inherently fallible, right? When you put a person in charge, like you mentioned, you add a certificate. Well, if you add their certificate and then rely on someone to document the fact that they added the certificate, then you're doomed to fail, right? So it's. Yeah. It seems kind of bad, but it really, if you're automating, it's all or nothing, or it should be. You should get to the point that you're not reliant on, because when people set up their data centers and they're all, their special purpose, this is going to be our Exchange server. This is going to be, those aren't cattle. Those are pets, and there's a problem.
So this was one of our big aha moments. So we went into a bank and we were helping a bank do automation, and they wanted us to do the backdrop of this story is they had a process that they needed to fit inside of a 2-hour window, and it was a 4-hour process. It was also failing 20% of the time. And so a 4-hour process that fails 20% of the time is actually a 5-hour process at best. It's really, on average, it's really an 8-hour process, because 20% of the time you're going to have to restart it. And so they needed to get that down into a 20-minute window. And so we have this nice image deployment system that really speeds things up, and it's very, very handy. And so we showed up and we're like, all right, we'll do your image deploy. That's great. We'll drop in the Windows, Linux, I think it's a Windows image, and get it going. And we could do that in 20 minutes. But what they didn't know, this is the crazy thing, is that they didn't realize that to complete that image install, they had about 8 different systems they had to connect into to complete the process. That it wasn't whether or not we could install an operating system and boot it inside of that window. The thing that actually was taking a lot of time was they had to register the machine with Active Directory, and they had to get Active Directory to respond, which was taking about 15 minutes. They had to run tower jobs in parallel that were taking a long time to complete. They had to talk to the remedy system and get a ticket. They had to, right? It's everything you're describing. It's like this menagerie of integrations was actually the thing that was breaking the provisioning deployment. And so that was the challenge. So as soon as you have something that you can't automate inside of a data center cycle, the whole system falls apart. That's why we ended up being an integration hub, not, an iDRAC, twiddler, or those are you have to do those really carefully also, but that's not where the challenge is. The challenge is somebody shows up on any day of the week and says, oh, I need to integrate to this other system, and either pull data out or push data to it as part of a provisioning cycle. And if you can't do that, then your whole process grinds to a halt.
Okay. So let's say, I'm in New York now, right? So let's say that and I've actually got buddies that have become CEOs since I've been here. So,
Cool.
it's not outside the realm of possibilities, but somebody taps me and makes me a CEO, and I've got an old school data center.
It could happen.
What's my first step? And I'm bought in. I love this stuff, right? So,
Yeah.
So how does someone even know where to get started?
So the thing that I've found to be really powerful, getting started is just in general speak, right? You got to start from where you have to think through how you're going to automate it. But what really is powerful in a getting started place is to figure out how you can create a complete chain of custody from that first bootstrap image. So anytime, right, it's much easier to fix something that is a new article. I'm going to put air quotes on new pretty hard, but in a second. But the idea here is that, and this is what makes cloud really powerful. The idea here is that if I start with something fresh, I want to have a completely automated process to go from a new thing all the way through the working delivered thing, connected into all of my other stuff. So I want to go through and figure out what those processes are. You can work that process backwards, meaning you can start at the end where it gets connected to everything, or you can start it at the beginning and then walk forwards. It's really hard to start in the middle of those processes, because what you really want to do is you want to keep showing that you have components. What we find is that people who are used to doing that in the cloud, like create a VM and wire it in and cloud init and then wire it into everything, people who are used to that thinking get really excited about what we do, because we've made it really easy to reset a server like it was a new cloud machine and then walk it through a full process. And then what happens is once you have that working, and you don't need a lot of new gear to get a process like that working, then you can go back and revisit infrastructure you already have. And then when you have that, then your resilience of that infrastructure has gone way up. And this is what I've really seen in how people are thinking about it. It's called immutable infrastructure. It's the way people usually like that term for it. And it's a confusing term for people because it means it's infrastructure you don't change. And what that says is we don't go into a place where I'm going to take a machine, get it set up, and then touch it, patch it, change it, do anything. I'm going to build a machine, and then if I need to make a change to it, destroy that machine, create a new one, and then run through my new process, my updated process. That's immutable infrastructure. And it's incredibly powerful, because if you're not immutable, then you're expecting your machines to drift, and configuration drift is really hard to maintain over time. So what we've been encouraging people to do, and what works really well in the clouds, is you never tweak things. You literally create a process that rebuilds it, does a complete reset, and then goes all the way through the process. For us and for our customers, that goes all the way back to setting RAID and BIOS, right? Setting the machine configurations, wiping the whole system. And the more often you do that, the more resilient your infrastructure.
Right. And that sounds, Ralph and I work for a company right now. I'm not a CEO yet, so fingers crossed though.
He's working on it.
We work for a company that does a lot of migrations of software, but not of hardware. And it's we use a lot of the same terms, right? Where, when we do a deployment of a service, you never go out and change the configuration on the service that you've deployed. You shoot it and you stand up a new one, and it's the same. It seems like and feels like the same sort of reasoning behind it as well, is because you want to be able to be at a given state reliably, and the more often you do it, the more reliable it is, because you've proven it. And so I really like the fact that when I become a CEO, I don't have to throw out all my old hardware. I just have to get maybe one new machine that I can set up right, and then start migrating the software over,
right?
And do some in place. And by the time I'm at the end, I might have 3 servers that I no longer really need using my old load, because I've consolidated things as well. Some things that we can do with Kubernetes.
You might. Well, I'm a big believer that we're going to see bare metal, Kubernetes on bare metal, and then that will actually be great candidates for people to take existing infrastructure, where they bought it, it's depreciated, it's still good gear, it just doesn't have, you don't want it to have a terabyte of RAM or something. Like, when we buy VM hosts, we max the machines with the processors and RAM, because we don't want a lot of those hosts.
Right.
If you're looking at a Kubernetes system, you're like, I don't need big RAM. I don't want big RAM. And so you're, all of a sudden you're looking at much less expensive, smaller commodity servers. And, a lot of companies have those sitting around from old workloads. It's a matter of reconditioning. I mean, and this is where, we were talking about COVID. If there's a supply chain problem, this is where the infrastructure resilience thinking comes in. It's like, all right, wait a second. with what we just described, you can say, you know what, today I've got this big, HPC cluster doing, analysis on my data. What if I wanted to flip over those servers to be VDI hosts, because now I have a lot of work from home people, or
Right.
I want to, that's resilience is when you can take your assets and repurpose them to something new. And you can't do that unless you can reset the whole systems, right? We're back to the immutable
Right.
artifacts.
Right. Otherwise, it becomes unmanageable because you got, bit twiddlers that are out having to do all of these settings. And yeah, so honestly, I've got in our office, and the reason I love iDRAC is because in our office, which is locked down, 28
Right.
Liberty, I've got an old Dell 720
Okay.
that I can iDRAC into, that I bought from Tech Mike, New York for like $800, and it's, it's got 144 gigs of RAM, it's got, it
Which is a
is that
respectable
machine.
amount of RAM. Yeah.
It's got, Xeon, dual Xeon. It's a decent machine, but I can log into it from here, mount a drive, but it's not the same because I still have to have an image. I can't do everything that I need to do on that one machine from here myself. But there are a lot of those old, 620, 640. There are a lot of those old Dell servers out there that
That's right.
could be running real workloads if they were treated well, if they were set up right. And as you say, and actually, let me ask you this, because this is something that's come up recently about Kubernetes clusters. Do you want one big cluster, or do you want little individual clusters for every? I've got to get religious with you here. Which is the right way?
It's funny. I did a blog post about that about a year ago. I think it went up on the news stack about thick versus thin clusters.
Mm-hmm.
It's here's my dilemma. I would love to see big multi-tenanted Kubernetes clusters, fundamentally I'd love to see a big infrastructure layer and it becomes the abstraction of choice. I don't think it's going to get there. Is the sort of short answer. One is multi-tenancy in Kubernetes is really not very mature.
Mm-hmm.
And so namespacing does not provide everything that you want it's not multi-tenancy. And, if you look at what we're seeing with CRD explosions and all of the other services that are starting to cluster around Kubernetes, now we've actually got every cluster has its own sort of fingerprint. Right? What CRDs did I implement? What versions are they at? What are the operators that are there? What services, what additional components do I have? And so once you get, a cluster with enough of these, extra limbs and attachments, it's not a Kubernetes cluster anymore. It's a workload specific, thing with Kubernetes underneath it.
Right.
So we're getting to a point where it's like, everybody has a skeleton, but you don't see it. And that's maybe that'll end up being this skeletons in your closet. I don't know. But that's the challenge, especially with Kubernetes being revisioned so quickly. Mm-hmm. You could be in a case where an API change or a service change is significant enough that you can't drag people forward. And my head explodes because that is very risky IT practice. As soon as you get into a point where you're locked on something, then now you've got drift, and a whole bunch of small clusters mean I'm going to have a maintenance nightmare.
Yes. Because each cluster is a pet, right? We've gone from where we wanted.
Nicely played. That's right.
I mean, that's right. It's where we end up, and one of the big reasons that where I'm working right now, they're talking about using smaller clusters is because of the upgrade nightmare. And how do you cannot do an in-place upgrade. And I'm like, well, you stand up a new one and you start draining nodes. I mean, how hard is it but it's hard. It's a non-trivial exercise unless you build it in from the beginning, as you've so eloquently put earlier. You're right. You do it often. You kill it. It's immutable. You don't do an upgrade. Why would you upgrade it? Kill it and move the workload.
Yeah, although moving workloads between clusters can be they haven't really designed a process to siphon, that would be I haven't seen anybody do this. Be interesting to see a process to siphon workloads from one cluster to another cluster. There's a huge networking problem because the networking doesn't span clusters from that perspective. So you'd have to figure out how to manage egress and state. And this is one of the things to me that really was an Achilles heel for OpenStack, and Achilles heel to me it's been almost fatal from that perspective. They never really spent time thinking, how do I do an upgrade in place? How do I make that bulletproof? How do I sustain, what that looks like? And Kubernetes hasn't really spent a lot of time doing that either. And even if Kubernetes does, all of the apps and CRDs and operators that you're doing on top of it also have to have thought through that process.
Right. And because everyone's a little bit different, you can't just paint with one brush. You're gonna have to
test every single one and make sure it works.
Yeah.
And this is the challenge of highly modular systems. I mean, now we're right. One of the things that we did with RackEnd was RackEnd is built on top of an modular infrastructure as code pattern. And everything that gets in the system is actually built as basically composable units that fit together. But when we did that, we ended up with feature flags so that you weren't checking a version number. You were like, is this feature implemented or not? And do I have another content pack? And like all the parameters we define are schema'd, so that you can say, okay, does it match the schema? And the schemas can get down to very exact regexes and lists and things like that, because we're always, and it's still hard.
It's even harder because you start out pushing the whole of your abstraction layer. You're pushing all of it at once instead of, a lot of times if you're just going to do something simple, your abstraction layers, you don't really make it that much. You start diving in, and as you get harder and harder, you get wider and wider. But what you're talking about with that kind of architecture, you're starting out wide, right? If you're pushing your schemas from the beginning and you're maintaining that layer of compatibility and backwards compatible all the way down with the feature flags are not easy.
Yeah,
I mean, feature flag
and defensive coding. I mean, this is the challenge of microservices, right? And we're seeing some good discussions on microservices now. Microservices are awesome because they facilitate individual teams to move much faster and not be tangled up with other teams from a release perspective. And that's great. But they also create a much more convoluted dependency graph. And so you might forward rev a service, change its behavior, and somebody who wasn't expecting the behavior to change, or you might not even been aware that you were changing the behavior, now is broken.
Yes.
Because you move forward. And so it's, the amount of defensive coding you need to do for these things is hard, because there's no big block coordination from that perspective.
Right.
And we see it writ large as we go through these things.
Cool. So infrastructure as code, though. I mean, let's what the 5 layers, right? So explain it to me like I'm 5. I'm a teenager. Let's get real.
Okay, and I have a presentation about this that people can go through, and I should probably pull up the presentation itself. Let's see.
Yeah, if you want to hit us up, we'll certainly link to anything and everything, because.
So there's a speaker deck that I have. We'll definitely get it into the show notes.
Okay.
About infrastructure as code. I was having an infrastructure as code Twitter thread, and it blew up on me, and it became obvious that everybody thought infrastructure as code was something different, and they were pretty mad about it. Actually, it wasn't as you might expect on Twitter, but I had one person who's like, it's just YAML. And I'm like, I don't think that's infrastructure as code. And so there's a huge aspiration of what people want infrastructure as code to be, which is, shiny robots making things happen. Let me see if I can find the actual pyramid that you're referring to. So I identified sort of 6 layers from this,
Okay.
and I will dumb it down so we can do the 6 layers for fifth grade consumption for infrastructure as code, which is going to be incredibly hard to do. Right. I mean, but here's what people want. They want their infrastructure, right, to be very predictable, very safe, right, and they want to be able to define it and then have it match the definition. I mean, fundamentally, when we talk about infrastructure as code, what people are saying is like, I want to write down what my infrastructure should be, and then I want to push a button and have it become that. And then really importantly is if they then make a change to the written definition, they want to push a button and have the infrastructure change to match the new definition. That's sort of what infrastructure as code ideally is. So when somebody says YAML, it's because they're thinking about programmatic configuration. That's like the bottom of the pyramid to me. And if they're thinking about like this magic of I push a button and good things happen, that's CICD on the other end. So the top of this is CICD Pipeline, where things go all the way through. Something we actually started calling CIDC, Continuously Integrated Data Center.
Okay.
For the concept, right? So you can imagine this pipeline where I put configuration in, I get, goes through the pipeline, I get, infrastructure configured correctly out.
Okay.
Fundamentally, that's infrastructure as code. In between those things, there's a whole bunch of requirements. So the pyramid stacks up. You need something cloud-like, but cloud is confusing as a word for people, so I prefer dynamic infrastructure, right? So I need infrastructure that I can say, make this change, and it has a way to make the change. So it's dynamic, right? You need some way to do desired state. So when you make, and this is what makes this hard. If my file says I need 6 servers and I only have 4, then when you change it from 4 to 6, that's a desired state change. So you need a way to match what you have versus what you want and make that change. That's desired state. So that's the middle tier. You need some way to have source code control, which is what we've been talking about in immutable infrastructure. So the idea here is that I have a trusted source of truth, whether that's GitHub or some other locked files or stone tablets. That doesn't. But you have to have some way to say this is what I believe is true, and this is our shared source of truth, right? Because you don't want Larry to come in and say, hey, it's this, and then Rob shows up the day, the next hour says, no, it's really that, and that's what we have today, and it's a mess. So you need some immutable sort of truth, and then to make that work, where it's like it's lay as a house of cards from that perspective. To make that work, you have to have composable automation. So all that stuff doesn't really work unless you've got this idea that I can pull together pieces. So when people talk about infrastructure as code, sometimes the as code part gets lost.
Right.
To me, it's very, very important that you look at how do I bring in all bits and pieces of other people's logic, code reuse. And you'd be like, Rob, how does that really pull into infrastructure as code? And the reason is because if you have to write all this stuff yourself, you end up with a spaghetti bash file. It's not good coding, right? You and I go back far enough. We can remember writing go-to lines in a basic program.
Yeah.
And that just does not scale. It doesn't work. So part of this whole thing is I also need a way to say, oh, I have a library that configures a Dell server. I don't want to ever have to think about that. I want to put in my configuration and let that library do it, because hopefully 1,000 people all will work together to make that thing consistent and repeatable, and I don't have to worry about the edges. So composable is a really important and really hard part of this whole story. And then once you have all that, then we're back to the CI/CD pipeline. So we go from I have a way to define it, and then all of those things sort of stack up into empowering a continuously integrated data center schema. And then all those things together to me are sort of implementing the vision of infrastructure as code.
Okay,
Long answer.
so
You want to?
well,
Yeah.
no, I get it. Excuse me, I get it. I think let me try to send it back to you to just to kind of in different words and make sure that we're on the same page, or at least I'm close. So if somebody writes down what they want for a server or a set of servers or just for their infrastructure, they write it down, and you have to have something that can then take that vision that they have and break it down or decompose it into parts, and then have something that knows how to take
Right.
an inventory of what pieces are available to make up those parts
Right.
and match them in some way, and kind of orchestrate the deployment of whatever code or processes are necessary in order to make the parts that I've chosen match up with the what I'm expecting it to look like, and then I come back and I say I'm done and it's all beautiful.
Right.
But it seems like there are each
It's layers.
stage
Yeah,
there
it's a
is
lot of
hard.
pieces. Mm-hmm.
I mean, just getting a server to match your requirements, much less defining what the requirements are from the initial vision. I mean,
Yeah.
there's a lot of steps in there.
There are a lot of steps in there. And that's why composability is really important. A lot of the steps shouldn't be that hard, and in some cases shouldn't be different. And this for us has been one of the big ahas, right? Installing Kubernetes doesn't care if it's on VMs, doesn't care if it's on Dell, HP, Lenovo, Raspberry Pi, right?
Mm-hmm.
Pis are a little weird because they are a different architecture. And so some of it does care, which is you have to, I have a favorite expression, which is abstractions are great until they're not.
Right.
And actually, it's a core architectural thesis for what we build at RackEnd. And the idea is that when you're writing software, you want to be able to say, you know what, if I knew these 6 things consistently, I could just continue on my merry way and never worry about it. And the way life is, unfortunately, is those 6, that's your abstractions. Like, give me 6 pieces, the interface I need and the IP address and my art, and then I'm good to go. And what happens is that works great until it doesn't. And you might be in a place to say, you know what, I'm actually building a bond and I need to know something additional information. And so the way all these systems work and the way a lot of these tools fall down is they're not very good at dealing with abstraction mismatches. Okay. And I have a really good example from the data abstraction object, DAO days. So like in Java and Ruby and things like that, they had these great wrappers for the databases. Mm-hmm. Right? Ruby, you had an amazing one. It was truly like you name things right and it's like just magic happens. And what would go on is that was amazing until you had a case where it didn't work right. And all of a sudden you're like, oh, wait a second, this mapping isn't right because I'm doing a disjoint join or outer join, and no, it's weird. And all of a sudden the whole thing blows up and you have to write everything by hand. So there's no gap, and you're either using the abstraction or it's in the toilet. Mm-hmm. And any program gets to be pretty quickly to a point where that abstraction, the abstractions break. And so when you build a system, especially one that deals with hardware, where there's a lot of variation and a lot of good variant, in those cases, you have to be able to come back and say, wait a second, I'm going to be piercing the abstraction all the time and reaching past it all the time. And we do that's normal. That's how you make it. It's funny. You make the system resilient by not making the abstractions too strong.
Gotcha.
And infrastructure as code has to be like that, where you end up with a very fragile system. Because as soon as your infrastructure as code comes in and says, oh, I want to run in Google instead of Amazon, and you're like, oh, wait a second, or actually I'll be more concrete. Linode, which we use a lot from a hosting provider and we like, doesn't use Cloud-init. They don't have that type of meta service. So now if I wrote an automation that depended on Cloud-init, it wouldn't be portable to Linode. I'd have to use their stack scripts. And if I use their stat scripts, it's not portable to Amazon. And so now I've got an abstraction boundary that's a problem.
Right.
It doesn't take, any journey through an infrastructure as code process to stumble into these use cases.
And I guess the question is, how do you sell it to the person who's at the C level, that's coming from a business background, that their question when somebody asks them about buying a computer is it going to be a PC or a Mac? That's the Well, no, it's in the server farm. Well, is it a PC or a Mac? That's how do you
hopefully there aren't too many people who are quite that
okay.
but yes, I understand. So how do you up level the IAC value proposition?
Yeah.
It's hard because what you're doing is you're saying, I'm going to be doing a whole bunch of work that you're not even going to see in order to make this happen. We have the same problem with CICD pipeline questions, although they've gotten better. It's one of the reasons we like the CI data center, CIDC, because the C-level people are like, oh, I need continuously integration, shift left thinking.
Mm-hmm.
But what you're really talking about is resilience and speed.
Okay.
So any of these most executives today are in favor of automated process, right? But they're also aware that automated process can be very fragile.
Okay.
And so what you're really trying to do is you're trying to say, look, I want to create a very automated process that is also resilient. And the only way to make it more resilient is to do it a whole bunch, which is what CI tells you.
Right.
And so a lot of what you're trying to do is you're saying, look, I want to make sure that when we build our infrastructure, we're doing it so automatically and so routinely that it's not something that one person has to know, the only one person ends up knowing how to do. It's not something where it breaks, but we don't find out for a couple of months, right? These are all what you're really doing is you're saying, look, this has to be part of the fabric of our daily lives. And that's when you look at infrastructure as code, what you're really trying to do is improve that day-to-day experience, that day-to-day use. And that to me would be, that would be part of that conversation. It's like, all right, look, we don't want, the automation that says, okay, I built the data center, 6 months ago. Let me go try and find the scripts and see if they still work.
Right.
When I go through and do that, that's what we're trying to get away from with this. One of the things that I like to think through, when I was in my IT diaper days and, just beginning, I remember people bragging about, I have a Linux system that's been up since 1970, at the beginning of the epoch. And so, people would brag about how long they had servers up. And I actually think that we should be doing the opposite, that we should be bragging that no server in my data center has been up for more than a month. Right?
Gotcha.
Your executive management should be saying, all right, think about the Equifax breach, right? They were sitting around, those hackers were lurking in the data center infrastructure for months. And if they had a process where they were repaving that infrastructure every month and resetting it and wiping it out, then, oh my God, the sleep factor for the whole IT team to be able to say, yeah, no, we haven't, every server we have has been re-imaged to corporate standard within the last 30 days.
Yes.
Right. The BIOSes have been patched. The OSs are all up to state, right? They are completely on current code. That's how people should be thinking about the data center. And that should be true in cloud too, by the way. If you're running a big cloud estate, you should be always rolling images in that infrastructure, right? It should, that's I don't care where you are in infrastructure. What I'm talking about for infrastructure as code is not a hardware thing.
Right.
That's the way you should be doing it, period.
And
go ahead.
Yeah, there are two things. So one, I will admit, no, it's a great soapbox. But I will admit that I had an app service. I work with a nonprofit, and they're running WordPress, and I recently had to update the version of PHP so that I could use the latest version of WordPress, because that app service has been running for 2 years, right? I've not updated it. And, oh gosh,
I'm guilty of the same thing.
But also,
Cobbler's own children. Yeah.
I want to back up though and mention that, we've talked a lot about servers, but infrastructure as code is also the switches, and it's the rest of the infrastructure that is in your data center, and that makes it more. I mean, it's SANs, right? I mean, it's everything.
It should be. We still have political silos. And that is a challenge. But yeah, I mean, for the stuff that we're doing, we're incorporating top of rack switch and imaging top of rack switch. The biggest problem is that you just get into get off my LAN. I did do it on purpose. Get off my LAN mentality with these other teams where they don't want you to touch the switches. They don't trust the automation to reconfigure it. And we really do need to figure out how to do more tightly integrated infrastructure. I think that's coming. I think when you look at what cloud has done and what the hyperscale vendors are bringing back into people's data centers, are very sort of integrated appliance like cloud stacks. We need to see more integrated infrastructure that doesn't require you to be locked in and tethered to a vendor.
Okay. So I'm coming out of this, and we're nearing our time here, but I'm coming out of this with two things that I need to look at, right? So one is I've decided that what I want to do is I want to run a truly heterogeneous Kubernetes cluster with Pis and maybe even like an iPad or something stupid,
yeah,
and some x86 and see get that running, but then maybe Kubernetes isn't where we need to live long term. Maybe there's something better coming around the corner. Is there something that I need to be looking at? Because like you said, Kubernetes didn't start out thinking about being able to drain a workload to a new version. And can we get there?
So one thing, if you're interested in Pis, we have a project called edgelab.digital.
Okay.
Where we took, it's not Pi, we started with Pis, so we actually did a completely infrastructure as code Raspberry Pi cluster. It's nice because I actually have one sitting on my desk. Maybe I'll show you. It's not going to translate to voice very well, but it's a beautiful little stack, power over Ethernet, so very clean. Yeah, but it's the same automation we use to drive multinational banks is running on those Pis. It's sort of cool. And so all the immutable infrastructure as code stuff, there's some like bootstrapping stories and things like that, all are built in for our integrations for that Pi, like Pixie booting and stuff like this. It's really cool.
Cool. Okay.
So that is a lot of fun from that perspective. And definitely check that out if you want to sort of play with this stuff. It's a $400 expense, and you can be booting it. And we used K3S for that. Because K3S is a very simple fork of Kubernetes.
Mm-hmm. Yeah, so real slim.
APIs. Yeah. For the Pis, it's absolutely perfect. For now, I would still invest in Kubernetes. It's well suited to the task. The containerization and microservices work that people do are going to translate. There is no immediate successor yet for Kubernetes, but as a bare metal company. Right, bare metal's here. It's not. It doesn't go anywhere. Right. But the things on top of that, do become flavor of the day. And so if you're building infrastructure, it's worth preparing for, this something's going to change in 3 or 4 years, and there's going to be the new, all the people in the Kubernetes community are going to be like, oh, that's so old. How can you be using Kubernetes? It's Netty Kubers now, and all the cool kids switched over to Netty Kubers.
Right. Well, I mean, Docker Swarm was hot, and now it's not. So
I've been hearing little ripples. I think because of the Mirantis acquisition, Hashi, which just got an unbelievable amount of money, has a Nomad, which is a reasonable competitor for that. I talked to the chef people with Habitat. There's good architecture design is good architecture design. It's not, it's not locked into Kubernetes as an architecture thing. But like Kubernetes is super safe. I wouldn't caution anybody away from looking at Kubernetes. The community is doing well. The product, the platform is really strong, and it has a great ecosystem. So not going anywhere soon.
All right. And I love your map in the back, by the way. The
Oh,
upside down, the
Southern Hemisphere focused. Yes.
Yes. That is a that's nice, because it resets your thinking, and that's what we're really trying to do with the cloud. So
exactly.
Perfect. Well, Rob, thank you so much for joining Ralph and I for the Cloud Talk show here, and I'm going to stop the recording. Any last words before I do?
Oh, I'm happy to give you, so if people want to hear more, right, RackEnd.com. The product we do is called Digital Rebar, which is not metal specific. So you could play with infrastructure as code concepts in our stuff all the time. I'm Zehicle on Twitter and most other places. So, if you want if you disagree with me, I'd love to hear that. If you agree it, that's nice too. And I'm on Twitter all the time, as Larry knows. Spouting off things and giving contrary opinions. So join in. We'll have fun.
All right. Thanks again.
Thanks.
And the recording is not stopping. Oh, there it is. Stop recording.